Today we will see the topic surface roughness in chapter production drawing. So what is surface roughness? So surface roughness means smoothness of the surface. Means how the surface is smooth after carried out any machining process or finishing process. Whatever may be the surface finishing process, an absolutely smooth and flat surface cannot be obtained. The machine components retain the surface roughness left after the manufacturing. The actual surface condition will depend upon finishing process adopted. To understand the concept of surface roughness, consider figure 2.3a, which shows a surface profile visualized by naked eyes. However, when the same surface is seen under microscope, magnified image of surface is obtained, which is shown in figure 4.23b. One can find that the same surface which looks flat and smooth is full of hills and valleys. If you observe these two figures, that is, this is the figure A, which is surface by naked eyes. If you see by naked eyes, then the surface will look like a flat surface. But the same surface, if you observe under the microscope, then the surface is having these hills and valleys. Hills means peaks, valleys means down. These are the hills and valleys. So this is the basic concept of surface roughness. So if you observe under the microscope, this is the structure of the. This is the characteristics of surface roughness. So different characteristics. This is roughness height, then waviness height, then waviness width. These are the widths of waviness. Then this is surface roughness width. Lay or direction of dominant pattern. Lay means this is the pattern. Which pattern is observed on the surface after machining. So this is the lay or direction of lay. So the surface roughness nomenclature for that, if you plot the graph of the sampling length L. So this is the sampling length L versus the height of these peaks and valleys. So the graph will be like this. These are the H1, H2, H3, H4, these are the heights of roughnesses, that is surface roughness height. If you integrate these heights from length 0 to L with respect to dx, then you will get this RA value. RA means surface roughness value. This RA value will be measured in micrometer. So the surface roughness will be measured in terms of micrometer. Then the direction of lay. These lay directions are different. So we will see one by one. This is the parallel. It's the parallel to the plane of projection of view in the symbol used. So if you observe, the direction of lay is parallel to the. This is the parallel lay of direction. Then perpendicular. The dominant pattern is perpendicular to the plane of projection. Then cross means this is the direction of ray is cross. Then multidirectional. This is the multidirectional M. Then C is concentric or circular, approximately circular, relative to the center of the surface, which is to be symbol is applied. This is the circular direction of lay, and this is the radial. So these are the symbols: parallel, perpendicular, cross, multidirectional, circular, radial. These are the directions of lay, which is to be used in general machining symbol. If you observe this general machining symbol, then in this general machining symbol at right side, the direction of lay will be given. So this is the direction of lay. Then next, general machining symbol. This is the machining symbols. The surface roughness is also indicated in the form of symbols on engineering drawing or production drawing. It can be shown by the following symbols. So what is the basic symbol of machining? So this is the basic symbol of machining. This consists of two legs of unequal length. This consists of two legs. These are the two legs. This is one leg. This is another leg. this consists of two legs of unequal length inclined at approximately 60 degrees to the line representing the surface considered. This is the basic symbol. It consists of two unequal leg lengths, and if the removal of material by machining is required, then simply one bar is added on this symbol. Then if removal of material is not permitted, then a circle is added to this basic symbol. If you add a circle to the basic symbol, then this will shows that the removal of material is not permitted. When a special characteristic is added, then a line added to the longer arm of basic symbol. If special characteristic is to be given, then a horizontal line is added to the basic symbol. Then next, indication of surface roughness on machining symbol. So this is the basic machining symbol, and this A will represent the value of surface structure or surface roughness which is to be achieved by any production method or any manufacturing method. The value of structure, the next, if the value of surface roughness A is to be achieved by machining process, then this symbol is used. Then next, the value of structure specified can be obtained without removal of material. So this is the symbol which shows the removal of material is not permitted, and this is A of value of surface roughness. Then if range of surface roughness is given, that is A1 and A2, then this symbol is used. Then special manufacturing method, that is milling, is used, means surface roughness is achieved by using the milling process, then this symbol is used. Then next, indication of special roughness characteristics. It is necessary to indicate the sampling length. Previously, I have told you what is the sampling length. This is the length which is taken for measuring the surface roughness. This surface roughness should be selected from IS 3073-1967 and stated adjacent to the symbol. This sampling length is stated at this below this horizontal line. So this is C is the sampling length. It is necessary to control the direction of lay. It is specified. Previously, we have seen the directions of lay parallel, perpendicular. So this is the direction of lay. If it is necessary to define the surface structure both before and after treatment, this should be explained by suitable note as shown in figure. Here, the surface structure before metallic coating is A1 and after metallic coating is A2. Next, this table will show the roughness grade. In first column, the roughness value, that is RA value, is given, which will start from 50 micrometer up to 0.025 micrometer. The next, roughness grade number. According to these values of my surface roughness, there are different grades. If surface roughness is 50 micrometer, then grade is N12, and if surface roughness is 0.025, then grade is N1. Means there are 12 grades, that is N1 to N12. Then corresponding to this, the surface roughness grade symbol is given. This 50 micrometer means N12 grade, and this is the symbol for this surface roughness grade. Similarly, 25 and 12.5, for that N11 and N12 are the grades, and this is the single triangle. This is the surface roughness grade symbol. Means this symbol will represent the grade number 10 to 11, and the surface roughness will vary from 12.5 micrometer to 25 micrometer. Then next, if you draw the two triangles, then the surface roughness will vary from N7 to N9 and 1.6 to 6.3 micrometer. If three triangles are there, then N4 to N6 and 0.2 to 0.8 micrometer. If four triangles are there, N1 to N3. Means if the number of triangles are more, means the surface will be smoother because the value of surface roughness is smaller. And if the number of triangles are less or smaller, only one, then the surface is rough, means the surface roughness will increasing from top to bottom, means surfaces becomes more smooth and smooth as we goes from this N12 to N1. Okay, so these surface roughness symbols are used in assembly and details on production drawing. From this you can identify what will be the surface roughness, smooth or rough surface. Then next is indication of machining symbols with all parameters on drawing. So this is the symbol with all parameters. So here you have to draw these unequal lengths, that is the basic symbol. When line is added, means this will be surface roughness is achieved by any machining process, and one horizontal line. So here the different parameters are there. How many parameters? So one is, we will see one by one. This is A. A is the parameter of surface roughness. This is the roughness value in micrometer or roughness grade. So this is the A, which is denoted on this upper side of the triangle. So on the triangle left side, this is the E, means machining allowance is given. So what is machining allowance? This is the allowance provided for any machining process. So this is the machining allowance. So on this triangle on the right side, the D, that is the direction of lay, is given. Directions of lay are different, that is parallel, perpendicular, cross, multidirectional, circular, radial. These are the directions of lay. Then on horizontal line, the manufacturing method is given. So manufacturing methods are different: milling, turning, machining, drilling, grinding. These are the manufacturing methods which is specified on the horizontal line. Then next C. So what is this? C is the sampling length. What is sampling length? This is the length taken for calculating the surface roughness, and F is the other surface value which is shown in bracket. So these are the parameters 1, 2, 3, 4, 5, 6. These are the 6 parameters of machining symbol. On these parameters, the machining symbol is dependent. So next we will see one example of this machining symbol. So here the problem is given like this: state the meaning of machining symbol as shown in figure. So this is the figure given. This is the general machining symbol, and you have to state the meanings of this. So what is this 8? 8 is the roughness grade. This is the 2 is machining allowance. Machining allowance is 2, and this is 0.8 is sampling length, and this is the manufacturing method is grinding. So this is the meaning of this machining symbol: grinding 0.8 mm sampling length having roughness value 8 micrometer with machining allowance of 2 microns. So this is the example of general machining symbol with all parameters. So in this way, in this geometric tolerances, we have seen, first of all, we have seen how to represent the geometric tolerances, then welding representation, then now we have seen the machining symbol and its all the parameters, surface roughness grades. So these all information is required in next chapter, that is assembly drawing and detail drawing. Okay, so in this way I will conclude this chapter of production drawing, and in next lectures we will start the assembly and detail drawings. Okay, thank you.